guys, so this is Savannah again, and I am going to be going over the advanced concepts presentation for Lab 5. I was a little behind with I applied to PA school and I took the GRE, and now I'm catching up on Biochem. And I was having a lot of iPad technical issues for a while. I'm literally on a borrowed laptop. So let's get started. So the amount of ATP made in all the cellular respiration pathways that we've been talking about that collectively literally help us live. So it starts with glycolysis, and in this I will be using this as my printout today. So glycolysis, as you can see, in the first, within, 3 of these steps, there's 2 ATP molecules used, and those enzymes that are going to help that is the hexokinase, which takes ATP, makes it into ADP, and as well as the phosphofructokinase. I just love these names. That's going to use up an ATP molecule too. But then we see later down here, there's the NADH, yay, and that gets made with the help of the enzyme glyceraldehyde 3-phosphate dehydrogenase. And that NADH molecule, there's actually multiple made depending on the substrate of how much NAD was in the substrate. But because it's in the cytoplasm, it's going to account for 1.5 ATP molecules versus later we'll see in the mitochondria, it'll account for 2.5 ATP molecules. So yay, we have some ATP made, and then later you see down here, this step right there, and let's see this step. The phosphoglycerate kinase and the pyruvate kinase also make ADP. Yay! So in here is, so ADP is used, you can see, and then this is my answer for the 30 ATP because, it depends on the substrates and such. So I wrote I guess we'll do that now. I wrote with the 2 ATP made and the NADH made that account for 1.5, that would be 5 ATP. And then through pyruvate oxidation, which with the pyruvate dehydrogenase complex, that does not use ATP, but it does make NADH, but because it's in the mitochondria, it just, like I said earlier, it's going to account for 2.5, so that's another 5 ATP made, and neither the TCA or citric acid cycle or Krebs cycle, whatever you want to call it, don't use ATP. So more for us. And so then here, just in this reaction that I wrote out with the 2 ATP made, the 6 NADH made accounting for 2.5 ATP, and then FADH2 made, which accounts for 1.5. That equals out to 20, and then plus the 10 ATPs up here, that would give you 30 ATP molecules. So, and then moving on to the pyruvate oxidation. Sorry, I kind of went out of order, but it just happens when you're on camera. So, once you have the pyruvate molecules, you undergo the oxidation of pyruvate to get acetyl-CoA molecules that can be inputted into the citric acid cycle. So here's this goes through E1, E2, E3, and there we see the NADH, and this is the pyruvate dehydrogenase complex. So this first part, it's collectively 3 enzymes that work at different stages. So the first one is pyruvate dehydrogenase. Yeah, E2 is dihydrolipotransacetylase, and E3 is the dihydrolipoyl dehydrogenase, which is the one that makes that NADH, which creates that accounts for the ATP molecules that are worth 2.5. So say you make 2 NADH. This is just a little bit more in depth of the complex reactions. So say you make 2 NADH in the mitochondria, you're going to have 5 total ATP from that NADH. Okay, and then, like I said earlier, the citric acid cycle, or Krebs, or I forgot the other name. TCA cycle. Doesn't use any ATP, but it sure does make some. So let's see. Isocitrate dehydrogenase is going to give us NADH, and it uses all those NAD pluses. So does alpha keto glutarate dehydrogenase complex, mouthfuls. And these are just taking out CO2s. Here the honestly, I haven't said this out loud ever in my entire life. CoA synthase. It's been a long day. Makes the ATP, and then the succinate dehydrogenase makes the FADH, which constitutes for 1.5 ATP, and another NADH made up there through malate dehydrogenase. So a lot of ATP is coming from NADHs on the citric acid cycle for sure. So you guys got to see some structures, some enzymes, heard a lot about ATP, NADH, and a little bit about FADH. So hopefully I answered your question, or FADH2, sorry. Hopefully I answered everything in the prompt. If not, feel free to reprimand.